Solving equations with radicals. This looks like an equation that has a radical. So x plus 1 under the radical equals 7. We need to figure out how we can isolate the x. And in order to do that, we need to get rid of, in this case, the square root. So how do you get rid of a square root? Well, to get rid of a square root, we square. So if I square this entire thing, I'll get rid of the square root. The square root of x plus 1 squared just gives us x plus 1. 7 squared gives us 49. So that means x equals 48. Let's try again. Say we have the square root of 5k minus 3 plus 2 equaling 0. Well, now we need to get this piece by itself so that when we square, we don't have this piece. Because be careful, I'll show you what happens with that later. So let's move our 2 over. So then we get the square root of 5k minus 3 equaling negative 2. So if we square, the square root and the square will cancel out, and we're left with 5k minus 3 equaling negative 2 squared is 4. Add your 3 to both sides. Divide both sides by 5. There we go. But wait a second. We should always check our solution just to make sure it works. So let's check over here. Well, I have 48. So we have the square root of 48 plus 1. So that's the square root of 49. 7 equals 7. All right, that one's good. Let's check the next one. So here I have, for the check, the square root of 5 times 7/5 minus 3 plus 2 equaling 0. So those cancel. So that's going to give me the square root of 7 minus 3 plus 2. So that looks like the square root of 7 minus 3 is 4. The square root of 4 is 2. Uh-oh. That doesn't work. That happens sometimes, which is why we always want to make sure that we check our solution. So in this case, we got 2 plus 2 equals 4, and that is not 0. So while we solved it through and our algebraic work was accurate, in the context of our question, the solution we got didn't work. So that means while we thought it was 7/5, it's really no solution. Let's try again. We have the square root of 3 minus x equaling x plus 3. So we want to get rid of that square root. So in order to get rid of the square root, we said that we square. But remember, when you square x plus 3, that really means x plus 3 times x plus 3. So the square root and the square will cancel on this side, so 3 minus x. But here we have to FOIL, which is going to give us x squared plus 6x plus 9. So let's set this equal to 0. Let's factor it down. So two numbers that multiply to 6 and add to 7. And then let's solve it. So here we get negative 1, and here we get negative 6. So we have two potential solutions. We need to check them so we can see what works. So let's check. We have the square root of, let's do our negative 1 first. So 3 minus negative 1 equaling negative 1 plus 3. So 3 minus negative 1, that's going to give us 3 plus 1, so the square root of 4 equals, and then on this side we had our negative 1 plus 3, so that's 2. Square root of 4 is 2, so that one works. Let's check the other one. So this one will be x equals negative 6. So we have our square root of 3 minus negative 6 equaling negative 6 plus 3. So 3 minus negative 6, that becomes 3 plus 6. So that gives us the square root of 9. Negative 3 plus 3 is negative 3. The square root of 9 is 3. 3 does not equal negative 3, so this solution doesn't work, which means x equals negative 1 is our solution. Let's try one more. So we have the x right here. Let's get the square root by itself, so let's move that x over. So we'll have the square root of 3x plus 1 equals x minus 1. Now we can square both sides. But remember, that means that we need to FOIL, so we have x minus 1 times x minus 1. So if we cancel our square and our square root, we get 3x plus 1 equals, let's do our FOILing, x squared minus 2x plus 1. Move your 3x plus 1 over. We can factor out an x from here. So we still have our two pieces that we can set equal to 0. We have x equals 0 from just this one, and we have x minus 5 equals 0, which means x would equal 5. So now we need to check them. So let's check. So how about we do x equals 0 first? So that's going to give us the square root of 3 times 0 plus 1 minus 0 equaling negative 1. So the 3 times 0 is 0, so that gives us the square root of 1, which is 1. 1 minus 0, that does not equal negative 1. So that means that x equals 0 is not going to work. Let's check x equals 5. So that's going to look like the square root of 3 times 5 plus 1 minus 5 equaling 0. 3 times 5 is 15. 15 plus 1 is 16. Oops. Equals negative 1 from right here. There we go. So we have the square root of 16. Square root of 16 is 4. 4 minus 5 is negative 1. That works. So that means our solution is x equaling 5.